Problem number 64, page 691, acid-base chemistry. This problem asks us to calculate the percent dissociation for a 0.22 molar solution of HClO2. We're also told that the acid dissociation constant Ka for HClO2 is 1.2 times 10 to the negative 2. Since HClO2 is a weak acid, it will only partially dissociate. We need to calculate the percent of dissociation, so we're going to have to set up an ice box to determine the concentrations at equilibrium. Here's the completed ice box with initial change in equilibrium concentrations. To determine the percent dissociation, I'm going to need to solve for X in the equilibrium concentrations. Using the Ka value and the expression for Ka, we can determine X and then determine the percent dissociation. Substituting in the Ka value and the equilibrium concentrations, we now have this expression to solve for X. Now in this particular problem, we cannot get rid of this X. We're going to have to expand this and use the quadratic formula. Getting rid of the denominator here, multiplying both sides by this, distributing this through here, moving everything to one side of the equation, setting the equation to 0. I now have this polynomial where I can use the quadratic formula to solve for X. Using the quadratic formula and solving for X, you get these two X values. We then have to pick which X value is the true value. Because this second X solution is a negative number and the concentration of H plus and ClO minus would be negative, this particular solution, the second one, is invalid. So substituting this X value into the equilibrium concentrations, you're going to get, substituting X that we solved for into the equilibrium concentrations, we then get these values for the equilibrium concentrations for each of the chemicals at equilibrium. Now to determine the percent dissociation, we're going to use our go-to percent equation, part divided by whole times 100. Our percent dissociation, the part that dissociated was 0.0457 molar. The whole part that was available was our initial concentration, 0.22. Doing the math, you'll determine that 21% of the HClO2 dissociated. Any questions?